The box plot is a very valuable tool for displaying data. Straight away, by looking at it, you can see the range of the data because you can see the minimum value and the maximum value. You can see the middle 50% spread, which is our IQR. You can see the median by this line in the middle. And so this whisker here is the bottom 25% of your data. The box is the middle 50% of your data. And this whisker is the other 25%. So just at a glance, you can see all that information. Now, in order to draw a box plot, we need a 5-point summary. The 5-point summary includes the minimum, the maximum, the Q1, the Q2, and the Q3 value, with Q2 obviously being the median value. So they are the only 5 things that we include when we're asked to state the 5-point summary. Now that 5-point summary again is going to help us draw our box plot, as will using our calculator, because we can get a lot of our information from the calculator. Let's just talk about outliers on our box plot. Now, we don't always have outliers, but what actually is an outlier? You can see the definition there. It's a data value that appears to be rather different from other observations. Well, what does that mean? If I was going to describe it, it's something that doesn't fit into the main group of data. So for example, if I had a class of year 11 students and in there I had a student who was extremely tall, perhaps a basketball player, so abnormally tall, he was much taller than the average, or perhaps I had someone in there who was much shorter than the main body of the group. Those people would be considered to be outliers. And we do have a way of being able to work out what those outliers are. We use these 2 rules. These will give us our boundaries. So anything bigger than this one would be an outlier in the top end, and anything less than this value here would be an outlier at the bottom end. So we're going to have a look at an example of that and see how it all pans out. But remember, there's not always going to be outliers, only sometimes. So what you're looking at here are the calculator instructions that will enable us to get our box plot on our calculator. And once you've got that, you'll be able to see all of the information that you need. You'll be able to read off your 5-point summary, you'll be able to read off your outliers, and you can use that to help you sketch the box plot as well. The number of hours that each of 33 students spent on a school project is shown below. So there are 33 pieces of data there, and they are the number of hours that students have worked on their project. Part A is asking us to state the 5-figure summary. Now, 5-figure summary, 5-point summary, 5-number summary, they all mean the same thing. So state the 5-figure summary. So what are we looking for here? We're looking for the minimum, we're looking for Q1, we're looking for Q2, Q3, and the maximum value. Now, we've put these all into our calculator, all of this data into our calculator before, into univariate, into lists and spreadsheets, and then one variable stats. And all of these things are easily read off there. They're also easily read off from our box plot, which you have the instructions for. So once you read those values off, you get the minimum being 2, the maximum being 264. Q1 is equal to 25.5. Q2, which is the median, being 71 hours, and Q3 is equal to 109.5 You can see that there's a very big spread of hours there. So one student spent 2 hours, another student spent 264 hours. So you can see the range is 262. All right, what do we need to do next? Part B wants us to identify any outliers if they exist. Okay, we need to use our rules here. So we do the lower bound, and anything that is less than that value is going to be an outlier. So the lower bound or the lower fence is equal to Q1 minus 1.5 times our IQR. Now let's just go back up here for a minute and work out our IQR. IQR is equal to Q3 minus Q1. So in this case, it's 109.5 take away 25.5. Now it's not part of your 5-point summary, but it is a valuable piece of information in order to work out our outliers. So when we work that out, we end up with 84. So that middle 50% of students, the range of hours was 84. It went from 25.5 hours up to 109.5 hours. So let's remember what this is all on about. All right, let's substitute that in and we get Q1, which we said was 25.5, take away 1.5 times. Now we've worked out our IQR, which was 84, and we put that all into our calculator and we get negative 100.5. Now, the question you're asking yourself, is there any values in your data being this information up here, is there any value in your data that is less than negative 100.5? And of course, the answer is no, because we don't have any negative values there. So now let's go and find our other side. So we'll be looking at the upper side. And so what we're looking for here is a value that will be bigger than that one. So the rule that we use for the upper side is Q3 plus 1.5 times IQR. Let's substitute it all in. And Q3 is 109.5 plus 1.5 times by 84, and we end up with 235.5. Now again, we ask ourselves, are there any values in our data being up here again? Is there any values in that data that is bigger than 235.5? So if you scan that data, you will find that there is only one value. It is 264. So therefore, 264 is an outlier. So we only have one outlier there, and it is 264. Now that is, when they ask you to show working out for identifying your outliers, that is the working out that is required. Part C asks us to construct the box plot. So let's start by setting up our axes. Like any other graph, you must always have an axis, and you must label your axes. So I'm going to go up in 100s here. So that's my scale. And what are those values? Well, they are the number of hours. So that is my label. So I must label my axes. I should also have a heading for my graph. So what is this graph all on about? Well, remember it was 33 students at the time spent on a school project. So I think something that would adequately cover that would be time spent on school project. Remember, a graph should be self-contained. So heading, label, scale my axes. My next part now is to sketch the box plot. Well, I usually start by sketching the box. Now the box goes from Q1 right up to Q3. Q1 being 25.5, 25.5, and Q3 being 109.5. So because of my scale being so large, it is approximate as to where it falls, but I always label my actual values there. So my min, my max, my Q1, my Q2, my Q3. What else do I know about this graph? Well, I know that the median is at 71. I also know that the minimum value is 2 and the maximum value is 264. But 264 was my outlier. So when I identify my outlier, I just identify it with a dot. So therefore, where does my whisker go to? Well, you can see on the diagram there that the whisker goes up to the next biggest value in my data. And the next biggest value in my data was 226. So my whiskers stretched on the bottom end from 2 up to Q1, and then from Q3 up to 226. And then the last bit of information that goes in is my outlier, which is at 264, which would be around about there for my graph. Okay, and there is my box plot. So let's just quickly summarise the important parts of this box plot. I have given it a heading. So a graph should always have a heading. I have got a scaled axis, which has been labelled, telling me what that axis is on about. And then I have drawn my box plot, making sure that if I have an outlier, that is identified. And I've also identified all of the points for my 5-point summary on my box plot. If you were to do all of that, you would get full marks for your box plot.